Hello, can you all
Hello.
hear me?
Yes, ma'am.
Yes, ma'am.
Okay, okay, just hold on. My camera is not working. I'll just switch on. Just 1 minute, all of you, please wait. I'm just something wrong with my. Can you give me the Hello, all of you are there?
Yes, ma'am.
Yeah, I'm sorry for this little bit of mess up because my camera was not working and then I had a little difficulty again. So let me share the screen now and we can continue. All of you can see the screen?
Yes, ma'am.
Yeah. Let me just check who all are there. So Ashwin, Hariharan, Sanjay, Sai Kalyan. Okay. Okay, so we will just for revision, we will start a few questions. Now let us see who will answer this first question. Who is going to answer the first question? Monochlorination of toluene followed by this question we have done once earlier. Let me see who remembers how to answer this question. Right, monochlorination of toluene in sunlight followed by hydrolysis with aqueous NaOH. So toluene is this. Yes, Hariharan.
The answer benzyl alcohol.
The answer is benzyl alcohol. Very good. Answer is benzyl alcohol. For those who were not present, like Ashwin Shiva, you were not present in the last class. So when I do chlorination, I will get Ashwin, are you there? Ashwin?
Ma'am.
Yeah, so can you see? This is benzyl alcohol. Very good. Now this question also I have done earlier. Who will tell me the answer? How many alcohols of molecular formula C4H10O are chiral in nature? Who will tell me the answer? How many, first of all, tell me how many alcohols can you write with C4H10O? Can somebody tell me? Sai Kalyan, are you there?
Yes, miss.
Tell me, what is the
We can do
answer?
like 3 isomers.
No, actually there are 4, right? This is one OH. Then this is the second one, OH here. This is the third one here. There's a branch here and a OH here. And this is the fourth one. There's a branch here and a OH here. Now, which one of them will have a molecule which is chiral in nature? Chiral means carbon atom which has 4 different groups around it. So you look at this one, CH3, CH2, CH, CH3. So look at this carbon atom. Can you see? This carbon atom has 1 hydrogen, 1 methyl, 1 ethyl, and 1 OH. So it has how many different groups? 4 different groups around it. And because of that, it is chiral in nature. So the first one is the answer. Only one alcohol with the formula C4H10O is chiral in nature. Here OH is attached to CH2OH. So it has 2 hydrogens. So it cannot be 4 different groups. Here OH is attached to again CH2OH. So it is not chiral. Here OH is attached to a carbon which is attached to 3 methyl groups. Right? So this carbon is also not chiral. So there is only one carbon which is chiral. What is the correct order of reactivity of alcohols in the following reaction? Tell me. One part of it is cut off, but anyway, in your answer lies in the fourth 3 only. Tell me, who will tell me? This time, Sai Kalyan, you answer. What is the correct order of reactivity of alcohols in the following reaction? In this reaction, which alcohol will react fastest?
Tertiary alcohol, miss.
Tertiary alcohol, and then secondary, and then primary. Right? So this is the correct answer. Now let us take the next. CH2, CH3, CH2OH. That is, ethanol can be converted to acetaldehyde by which of the following? We did reduction reactions in the last class. Which of the following can convert ethanol to ethanol? Tell me, who will tell me the answer? Who will tell me the answer?
Is it option 3, ma'am?
Yes, option 3. Hariharan, I'm so happy you have revised and come. You are answering all the questions. Very good, Hariharan. Keep it up. Then the next one, process of converting alkyl halides into alcohols. Okay, alkyl halide into alcohols involves what type of reaction? Is it addition, substitution, dehydrohalidination, or rearrangement? Who will tell me? Ashwin, what is it?
Option 3, miss.
No, alkyl halide to alcohols. I'll write here. This is alkyl halide with aqueous NaOH. What happens? Cl is replaced by OH, CH3OH plus NaCl. Now tell me, what type of reaction is it? Sai Kalyan, you gave a wrong answer. Tell me. What is it?
Substitution.
It is substitution. Is that Ashwin Shiva?
Yes, ma'am.
Very good, Ashwin. Very good. Answer is substitution reaction. Sai Kalyan, did you understand what is your mistake? You
Yes,
said,
miss.
yeah, we are not preparing alkenes, we are preparing alcohols. Now, which of the following can be used to convert RCHO to RCH2OH? That means reduction. Aldehyde to alcohol. Now, here you can have more than one answer. Okay, now tell me, which of the following? You can convert RCHO to RCH2OH. What is RCHO? RCHO is an aldehyde, right? So we have to reduce it. R, C, H and double bond O. If I reduce it, what will it become? RCH2OH, right? So I have to use a reducing agent. Which of these can reduce it to? So the answer, anyone who can give me this answer?
Is it 1 and 2, miss?
It is 1, it is 2, and also 3. NaBH4 also can. It acts like lithium aluminum hydride only. So the 1, 2, and 3, all of them can convert aldehydes into alcohol. Very good. Which of the following reactions will yield phenol? We have already done methods of preparation of phenol. Which will give phenol? Tell me. These are the 4 choices. Which one of them will first one give phenol? All of you answer together. Can first one give phenol? Quickly.
Yes, ma'am.
Yes, first one can give phenol. This is correct. What about the second one? Will it give phenol? Sai Kalyan, will it give phenol?
Yes, ma'am.
Yes, second one will also give phenol. Third one, will it give phenol? Third one will also give phenol, right? Aqueous NaOH. This one will not give phenol because you need high temperature and high pressure. Here, high temperature and high pressure is not there. So you fourth one will not give. Which of the following reagents can be used to oxidize primary alcohols to aldehydes? Who will answer this question? Quickly tell me. Today what happened? Only 3 of you are there. No, 6 more have come. Who has come now? Ashwin, Shiva, Hari, Haran, Hari Raghav is also there now. Yeah. Tell me.
Miss,
Yeah.
other than option 2, everything will give, Miss.
Yes. Other than option 2, no. Option 2 also. So heat in presence of copper. This is other than option 4. Option 4. No, D, that is D. No, option 4 also gives. Pyridinium chlorochromate, this.
Ma'am,
Yes, you are right. Other than, we are making only aldehyde. So other than option 2, all of them will give. Correct, Sai Kalyan, you are right. Because this will form acids. We want to make only aldehydes. So first 1, 3 and 4, they can all make aldehydes from alcohols. All right. So quickly before we start more, I want to go through the slides to remind you because last week I didn't take any class. So there's a long gap. On Saturday, I wanted to take a class, but many of you didn't appear. So I had to cancel the class that day. So that is why let us quickly go through the slides. So we learned, we started with the alcohols. Just see this. Right? So we started different types of alcohols where all we find wherever the word is ending in all, it is an alcohol. Classification of alcohols we did, then monohydric alcohols, then we did nomenclature of alcohols, then we did different types of monohydric alcohols, allylic and benzylic alcohols. We talked about phenols. Then we started preparation from alkenes, how will you prepare alcohols, Markovnikov's rule. Then we learned how to prepare alcohols by hydroboration. Oxidation, it is like anti-Markovnikov addition of water, the product is like that. Then we talked about this preparation from alkyl halides, then from aldehydes and ketones, and we did sodium borohydride, and then NaBH4, all these reducing agents we talked about, NaBH4. Then we talked how to prepare alcohols from aldehydes and ketones. Again, another method which I showed you, the Grignard synthesis, which is very important. And we learned to prepare primary, and then we learned how to prepare secondary alcohols. And then we did some MCQs here. Secondary alcohols, then we learned about how to make tertiary alcohols. And then we learned how to make different alcohols using Grignard reagent. Then we learned preparation of phenols. After preparation of phenols, we learned physical properties of alcohols. Then how do you prepare phenol from benzene sulfonic acid? That slide has got shifted. And then we talked about chemical properties, the acidic nature of alcohols, combining the acidic nature of alcohols with comparing with alcohols, phenols, and to understand why primary alcohols are more acidic than tertiary alcohols. All these things we have done in the previous classes. Then we did esterification reaction, and then we did acetylation reaction. I talked about the salicylic acid and how the esterification reactions can give you many useful products. Then we talked about second type of reaction where OH group breaks. So we talked about reaction with halogen acids. We talked about reaction of Lucas reagent. Then dehydration of alcohols. And then we talked about the mechanism. Then elimination of reaction of alcohols. Oxidation of alcohols, right? And we talked about different oxidizing agents and how they can oxidize either to aldehydes or to acids. Then oxidation of secondary alcohols, dehydrogenation using copper at 573, and then we did some conversions. So that is where we stopped. And now today we are going to focus on reactions. Now this weekend you have a test, children?
ma'am.
Yes or no?
Yes,
Yes,
miss.
ma'am.
Yeah. So now we are going to take the reactions of phenols. Okay, I must finish it in by today and tomorrow so that you are prepared for the class or for the test on the weekend. Okay, so we'll take the reactions of special reactions shown only by alcohol, phenols. Now, for understanding the reactions of phenols, first look at phenol. It will show reactions due to the OH group, which are like reactions of alcohols. And it will show some reactions due to the benzene ring. Now, first, let us see what reactions it can show to the due to the benzene ring. Now, what is the influence of OH on the benzene ring? Now, OH group is ortho para directing. It is ortho para directing. And it also activates the benzene ring, activates the benzene ring. Activates the benzene ring. Okay, now first we have to understand, because there are always questions about why OH group is ortho para directing and why does it activate the benzene ring. Can anyone tell me why? You have learned this in class 10, class 11, I think, but if you don't know, I mean, if you already know, I should understand that. Do you know how to write the resonance structures? All of you, tell me. Sai Kalyan, do you know how to write the resonance structures?
Yes, miss.
Hari Haran, Hari Raghav, do you know how to
Yes,
write
ma'am.
the resonance structures?
Yes, ma'am.
Okay, very good. So let us quickly write down the resonance structures. What is the trick of writing resonance structures while doing chlorobenzene? I showed you. So the first thing is you write phenol and write phenol once again, but show different positions of these bonds inside the ring. So this is the other possibility. So first write these two. This is the first structure and this is the last, which is the fifth one. Now to write the resonance structures properly, write all the benzene rings together. First write benzene ring 3 times. This is the best way to arrive at the structures correctly. You write the ring only, not the bonds inside. Write the skeleton. Okay, so O and H. Write the skeleton. Okay, no double bonds and no bond pairs and lone pairs are not shown. Now you show the change in the first one and depict it in the second one. Now, when an electronegative element is singly bonded to the benzene ring, always the movement of electrons is towards the ring. So these electrons, they repel this one here and they come and take the place here. So this bond pair, lone pair will become bond pair. So what will it become? Double bond. This bond pair will become lone pair. So it will come outside. So this will become negative. This will become positive. No change in the rest of the molecule. This is the first resonance structure. You connected with a double-headed arrow to show that it is a resonance structure. Now, what is the next one? This will repel this one here. So lone pair becomes bond pair becomes lone pair. So you will show that here. So this and this is negative, this is same. Here, no change. Now the next one, this will move on here and this will come to take the place. So you write it here. This will become negative and this is positive. Lastly, this will come here and this will go back there. So you will get this structure. So you get the 5 resonance structures. Now, where does the negative charge reside in this? It is on ortho and para positions. So what is the influence of OH group on the benzene ring? It is ortho-para-directing. And this is plus M effect. The benzene ring is being activated because of plus M effect. Okay, so it is plus M effect, so it is activating and also ortho-para-directing due to what? Due to plus M effect. So phenol will show all the reactions on the new electrophile will come on ortho and para position. So due to benzene ring, you have learned already in chlorobenzene, what are the types of reactions? The types of reactions are electrophilic substitution reactions. Substitution reactions. Okay. So let us look at all the electrophilic substitution reactions of phenol. Now, when we do electrophilic substitution, I have already told you there are different types of substitution reactions of phenol. First one of the benzene ring. Always there are 4 substitution reactions. What are they? Halogenation, nitration, sulfonation, and Friedel-Crafts reaction. Whenever there is a benzene ring, these reactions always happen. So first, let us take halogenation. What is halogenation? Introducing a halogen on the benzene ring. So I can do halogenation here. The halogenation that I will do is in 2 ways. First, I will take bromine in presence of a non-polar solvent. Non-polar solvent is in presence of carbon disulfide at 0 degrees Celsius, or you can write 273 Kelvin. Okay, because I want to slow down the reaction. So what will happen? This is my phenol, OH, and when I react it with bromine, right, a Br will come on the benzene ring. So I will get orthobromophenol and I can also get parabromophenol. Okay, this happens only if the temperature is low and the reaction is carried out in presence of a non-polar solvent, 273 Kelvin. However, if I take phenol and I react it with bromine in presence of water, okay, so if I do the same thing, OH, and I react it with bromine in presence of H2O, if there is water there, so it becomes bromine water. Then what will happen? This is activating also, so OH will be there and Br will come on ortho as well as para positions. Okay, I can write 3Br2 plus HBr. Okay, so here I'm right, not the first equation cannot be balanced because the percentages are different. Here you can balance and show the formation of HBr. So this is a reaction when you use a polar solvent. Here the polar solvent helps and this is non-polar. So if you want only mono-substituted product, you choose a non-polar solvent. Otherwise, you use a polar solvent. So that is halogenation of phenol. Now, supposing I have to do second reaction. Second reaction is nitration of phenol. Nitration of phenol. How do I do nitration reaction? What are the reagents that we use? Is a nitrating mixture, which is always concentrated HNO3 and H2SO4 also concentrate. So if I take a nitrating mixture and I do nitration, then what will I get? This is phenol, OH, and I will add here HNO3. Let me write it on the arrow. If you write the reactants on the arrow, children, the advantage is you don't have to balance the equation. So concentrated HNO3 and H2SO4, you write the line. And what will be the product? You will get a NO2 on the benzene ring, right? And not only on ortho, but also on both ortho and para position. This compound, I've already told you the name. It is 2,4,6 trinitrophenol. 2,4,6 trinitrophenol. It is known as picric acid. Why do we call it an acid? Because of the 3-nitro group. Phenol is anyway acidic in nature. Because of the 3-nitro groups, it becomes highly acidic in nature. So that is 2,4,6 trinitrophenol. Now supposing I want to get only ortho or para nitrophenol. So I take phenol, and this time I do nitration in presence of dilute nitric acid, dilute HNO. In that case, I will get a mixture of orthonitrophenol and paranitrophenol. And if you can remember, I have told you orthonitrophenol and paranitrophenol, which of them has a higher boiling point? Can you tell me? Anyone? See, children, you don't switch on your cameras. And you don't even talk in the class. How do I know whether anyone is there? Earlier I used to see your presence on the screen by even if your camera is not there. I told you, if you are there now in Zoom, I don't see unless every time I have to see how many participants are there. If somebody disappears in between, I will not know. So at least you should say sometimes, okay, yes, I should feel I am teaching somebody, not a wall. I'm not teaching a computer. So if you just keep mum all the time, how is it going to be? I can't keep asking, okay, Sai Kalyan, tell me. Okay, Hari Raghav, you tell me. Sometimes you should respond, shouldn't you? Somebody has already left. Who left now? Hari Raghav is coming back. Did you all understand? Now, can you tell me which one will have higher boiling point? Sai Kalyan, today you are not answering at all. What happened?
Miss Para, Miss.
So which one will have a higher boiling point? Orthonitrophenol or paranitrophenol? Can you tell me?
Paranitrophenol, Miss.
Paranitrophenol will have higher boiling point. Correct. This one has higher boiling point. Why orthonitrophenol has a lower boiling point? Because this one shows intramolecular hydrogen bonding, right? And this one, yes. And the other
boiling
one,
point for metal.
boiling point of orthonitrophenol is lower because there is within the molecule there is hydrogen bonding. So there is no intermolecular hydrogen bonding. But here there's intermolecular hydrogen bonding. So you need to give it more energy to separate. So boiling point is higher. Here this is volatile actually. This is volatile. Why? Because there is within the molecule. So between two molecules, there's no hydrogen bonding. It is within the molecule. So that all the molecules are happy within themselves. They don't attract each other. When they start attracting each other, then the boiling point rises. Understood? Okay. So that was nitration of phenol. Now, the next one, these are the important reactions of nitration and also halogenation of phenol. Now there you could have written, although it is not important, but let me show you reaction with CH3Cl. This is Friedel-Crafts reaction. Friedel-Crafts. This is alkylation, also known as alkylation of the benzene ring. So if I take phenol, okay, OH, and I reacted with CH3Cl, what is the catalyst for Friedel-Crafts reaction? It is anhydrous AlCl3. So what will I get? I will get here OH and CH3 on ortho plus CH3 on para position. OH and CH3 on para. So orthocresol and paracresol. It is known as cresol. And I would rather write CH3Cl on the ring, so on the arrow, so that I don't have to balance the equation here and anhydrous. Okay, so these are few reactions of benzene ring which are due to the ring present in phenol. Okay. Now we will take a few other very characteristic reactions of phenol. The fourth reaction, so three reactions are done. Now the fourth reaction, it is called Kolb's reaction. This is a very important reaction of phenol known as Kolb's reaction. So what is
Miss,
Kolb's reaction? Yes, tell me.
when we react with CH3COCl, that is Friedel-Crafts acylation, other than CH3, we'll get OCH3, miss.
Yeah, if I do a Friedel-Crafts, let me show you that also. I anyway wanted to take it on the next page. So if I do here OH, right, and I just take CH3COCl, this is a good question you have asked. Now this CH3COCl will, if I just take CH3COCl without acetylation, then what will happen? Without Friedel-Crafts catalyst, without AlCl3, then what will happen? The reaction will occur at the benzene, at the OH group. I told you acetylation reaction. So it will become OCOCH3. Okay, this is phenyl acetate. I will get phenyl acetate plus HCl. But if I do the reaction in presence of AlCl3, right? This is very important to understand. If I take OH and I do CH3COCl in presence of AlCl3 anhydrous, right? Then what will happen? I will get OH and COCH3 on the ortho or on the para position. Right? Orthohydroxyacetophenone, para-hydroxyacetophenone. So this reagent can make all the difference. Okay, so did you understand? So that is Friedel-Crafts acetylation. If it is acetylation, then the reaction is at OH. If it is Friedel-Crafts acetylation, then only it comes here. Okay. Did you understand, Sai Kalyan?
Yes, miss.
Now we will do this Kolb's reaction. This is also a very important characteristic reaction of phenol. Okay. Now for doing this reaction, the first step of the reaction is that you take phenol, and you know phenol can react with NaOH. Phenol is acidic enough to react with NaOH. So you reacted with NaOH. So what will happen? Again, I am making a mistake of writing, because I should not write the byproducts, nor I need to balance the equation. So first I will write NaOH. So NaOH reacts with the OH group of phenol and it becomes ONA. This is sodium phenoxide. Now, sodium phenoxide, why do we convert it to sodium? Because sodium phenoxide has a highly activated benzene ring, even more activated than the benzene ring of phenol. So very, very weak electrophiles can attack the benzene ring. So what do I do now? I react it with carbon dioxide. Okay, carbon dioxide first. And then I react it with acid. Why do I react it with acid? So that I again changes into phenol. So COO, what happens is first here is O minus, and here on the ortho position COO, or what is that CO? From carbon dioxide, and H plus attaches here as well as here. So what do you get here? You get, I already showed you, introduced this acid to you, salicylic acid. This reaction is called Cole's reaction. It's a very important reaction. Wherever there's a name reaction, you have to remember. Now this happens under high temperature and pressure. You have to mention here high temperature and high pressure. So under these special conditions, phenol changes into salicylic acid. So this is by Cole's reaction. A similar type of, so what is the electrophile you should remember for Cole's reaction? The electrophile in the Cole's reaction is carbon dioxide. Okay, although it is a neutral electrophile. Why does it act as an electrophile? Because carbon is attached to two oxygen atoms like this. So this oxygen is pulling electrons, this is also pulling towards itself. So carbon is, you can assume carbon is for some time electron deficient, so it can act as an electron. Now the next one is also a very, very, very important. I should call it a 5-star reaction. It is known as Reaumur-Tiemann reaction. Reaumur-Tiemann's reaction. This is also a similar reaction. In this reaction, you take phenol and you react it with what? Chloroform, CHCl3 and aqueous NaOH. CHCl3 and aqueous NaOH. So what does NaOH do anyway? It does the same thing. This is the first step of the reaction. This changes it into ONA. Whenever there is OH, phenol will react and form ONA. And CHCl3, it attaches at the ortho position. The mechanism of this reaction is quite complicated. So I'm showing you the simplest form. So you can assume that one H from this ortho position and one Cl from chlorine is removed, and HCl and CHCl2 comes and attaches here. And then again, since NaOH is already present, what does aqueous NaOH do? You have learned in haloalkanes. It replaces Cl with OH. So what will it do? It will replace Cl with OH. So this is what you will get, ONA, and this will become CHOH and OH. Now, two OH on the same carbon are not stable. So what will happen? Water will be eliminated. So minus H2. So what will I get? I will get here ONA. And here I will get CHO. And if I add H plus now, it will become this compound. OH. And here CH. So the other one was salicylic acid. What is this? Salicyl aldehyde. Okay, why should we learn this complex reaction? Because the product that you get is very, very useful. I have already shown you earlier, salicylic acid can be converted into aspirin. It can be converted into peppermint. It can be even converted into a disinfectant called Savalon. During this COVID times, we were using Savalon. So all those things can be prepared directly from salicylic acid. So you can learn all these steps if you want to. Otherwise, you can directly write here. On the arrow, you write just CHCl3 and 1, and then 2 is NaOH, and 3 is H+. So if you do all this, you can directly get salicyl aldehyde. What do you call this reaction? Reamer-Tiemann reaction. Reamer-Tiemann reaction. So this is reaction number 5 for phenol. Now let us look at reaction number 6 of phenol. Phenol is a very, very important compound, and all reactions are very different. We have to just revise them repeatedly and then learn them. Next is fifth one is reaction with zinc dust. This reaction is also very important. Why? Because it helps in getting rid of the OH group on the benzene ring, because you use this reaction in conversions. How will you convert phenol into toluene? Let us do that. So this is zinc dust. You write zinc dust. What will happen? This phenol will change into what? Benzene plus zinc oxide. Okay, so OH is just simply removed and you get benzene ring. So where do you use this reaction? Suppose you have to convert phenol to toluene. Okay, what is toluene? Toluene is methyl benzene. So first, what will you take? Phenol. And with zinc dust, what will you do? You will convert it into benzene. Or I can say phenol to chlorobenzene. So let me make it chlorobenzene, because these are the two things you have learned. Phenol to chlorobenzene. So what will you do now? You will do chlorination in presence of AlCl3. You will get chlorobenzene. So in order to introduce Cl, you have to just first get rid of OH. So this is a very useful step of doing this. Then just like we learned for acids, we should also learn the last reaction of phenol, that is oxidation of phenols. Phenol can be oxidized easily. How? You know, in the lab, when you see phenol, you often find phenol which is light pink in color. So even when exposed to air, it gets oxidized. So you always store it in dark bottles. So there is sometimes a question, why do you store phenol in dark bottles? Because phenol has a tendency to get oxidized easily. So this is phenol, OH. And in presence of any oxidizing agent, even with air, you can take Cr2O7 and H+, Cr2O7 2- and H+. It will get oxidized into a compound like this. This is called benzoquinone. Benzoquinone. And benzoquinone is pink in color. So if it is partially oxidized also, phenol appears to be pink in color. I told you what is the physical state of phenol. Phenol is, they are crystals which melt at just 42 degrees Celsius. So that is about phenol. Now we will talk about a few other things and then finish phenol alcohols. So the few other things are two special methods of preparation for preparation of methanol. Preparation of methanol. This is also separately in your syllabus. Large scale preparation of methanol. How do you prepare methanol in large scale? So methanol, another name of methanol is wood spirit. Okay. Why do you call it wood spirit? Because from wood you get methane, and methane on oxidation can give you methanol. So what you do is you do destructive distillation of wood. Okay. So first you do destructive distillation of wood, um, and you can get methanol, and that is why methanol is known as wood spirit. But nowadays, how you prepare it? By doing catalytic hydrogenation of carbon monoxide. So what you do is carbon monoxide plus 2H2. And you do hydrogenation reduction of carbon monoxide in presence of two catalysts, zinc oxide and chromium Cr2O3, chromium oxide, keeping the pressure at 200 atmosphere and temperature as 573 Kelvin, about 300 degrees Celsius temperature. So if you do that, you will get CH3OH, right? Sometimes you make water gas and then add hydrogen. Water gas, you know what it is? You take red hot coke and you pass steam over it. This is red hot, and you pass steam over it. So CO plus C plus H2 will give CO plus H2. This is known as water gas. Okay. And then you mix water gas with hydrogen. Also, you can make methanol. So there are different ways. This is the one mentioned in your book. So I just thought I should tell. Now, methanol is a colorless liquid, but it is highly poisonous. It causes immediate blinding. Okay. Now, you know, ethanol is used as liquor, but ethanol is also used extensively in the industry. Now, in the industry where ethyl alcohol is used, there's always fear that people might misuse. People, you know, the worker will go to the factory to prepare something out of methanol. It is so, you know, how addicted people are to drinking and liquor. He might drink, and then, you know, to prevent misuse of alcohol as liquor, what people do in the industry, they mix it with a little bit of methanol so that it becomes unfit for drinking. So that methanol, which is mixed with that alcohol, which is mixed with methanol, it is known as methylated spirit, right? So normally you cannot get spirit easily. The spirit that you get is always methylated spirit. So now, you know, those people who want to, you know, give cheap liquor, they somehow manage to get this methylated spirit. That is why when they are not able to mix the methylated spirit carefully, many people die of drinking. That is called spurious liquor. You know, these terms are used. You will get those type of questions where you have a paragraph. So spurious liquor. So spurious liquor is actually methylated spirit. So people die of, you know, drinking. You must have heard of liquor tragedies. What are liquor tragedies? When people drink spurious liquor or methylated spirit and they either become blind or they die because of drinking that liquor. So if you even take small quantities of methanol, it can cause blinding and even death. Now, in case you get, you know, there's a way by which, you know, supposing somebody is suffering from poisoning of methanol, then how you actually save that person. There are ways to do it. I don't remember it right now, all the steps, but you can sometimes give more alcohol to the person to save him from the methanol being absorbed. So if methanol and ethanol are mixed in liquor, what happens when you drink? Then methanol is it gets absorbed by your brain much faster than ethanol, and it starts affecting it there. So that is preparation of methanol. Then the next is preparation of ethanol. Preparation of, yes.
Miss,
Tell me.
if they ask the questions, preparation of methanol and preparation of ethanol in the exam, it's necessary that you should use only this. Can't we use a common sense and
No, you can. If they say only write up, they will not never ask write a preparation of methanol. They always say, how will you prepare methanol? Because these two methods are specially mentioned in your syllabus. So they always will say, how will you prepare methanol from carbon monoxide? Or how will you prepare ethanol by fermentation? Only then you should mention. If they don't say this, then you make by whichever method you like. You don't have to use this method. Then you can start from methyl chloride, use aqueous NaOH and get methyl alcohol. You don't have to prepare by this long method, right? So depends on the question. But these two, if you look in your textbook, you will realize these two methods are specially mentioned. That is why I am just taking it up. Now, why it is preparation of ethanol by fermentation? Why does? Because the whole liquor industry depends on this method. Why is ethanol so important? All governments, why don't they ban liquor? Is my question. Always I think so many people get addicted, they spoil their lives, they die, their livers get damaged. Still people go on drinking, wasting their money, their life on alcohol. You know it. All of you know that. Why isn't that the governments don't ban liquor? There are a few states where liquor is banned, but not all states. Why? Because there is extremely high excise duty. So the government earns a lot of money from alcohol. And that is why they want to sell alcohol. And people are fools. They keep buying and they get addicted. They waste their hard-earned money. Sometimes they don't earn. Especially in the poor classes, you would have heard the women go to work and the men sit at home to drink. In Maharashtra, it is very common. I don't know how it is in Tamil Nadu. So preparation of ethanol by fermentation. So there are fermentation you always do of carbohydrates. I don't know whether you understand what carbohydrates are. We are going to do one topic on carbohydrates also, biomolecules. But I hope you know that all the fruits, they contain carbohydrates. What are the carbohydrates? Like glucose. Okay, C6H12O6, it's carbohydrate. Sucrose, C12H22O11, that's also a carbohydrate. You know, starch is a carbohydrate. Where do you find starch? In rice. So anything which contains a carbohydrate can be literally converted into liquor or ethyl alcohol by fermentation. So what is the process of fermentation? I can take sugar solution. Where do I get sugar from? From sucrose. So it comes from sugarcane juice. So what happens is sugarcane juice is used to convert sugar, is used in the sugar industry to make sugar. So after sugar is removed from sugar, prepared from sugarcane juice, the remaining sugar, it is changed. What remains is in the form of molasses. Molasses is the mother liquor from which sugar is obtained. So molasses still contains a lot of sugar. So molasses is converted into, ethanol. And how is it sold in the market? This is not in your syllabus, but I'm just telling you for your general knowledge. It is sold by the name of a liquor called rum, R-U-M, rum. I don't know whether you have heard of. So molasses contains the C12H22O11. This is sucrose. So first, in presence of water and an enzyme, this enzyme is present in yeast, which is a fermenting agent. Yeast contains an enzyme called invertase. So invertase converts sugar into glucose and fructose, C6H12O6. So this is glucose and fructose, they are isomers. So it changes it into a mixture of glucose and fructose. Now this C6H12O6, whether it is glucose and fructose, it reacts with another enzyme which is also present in this yeast. It converts glucose into alcohol. So you get 2C2H5OH plus 2CO2. All right. So you can convert any carbohydrate into alcohol. This process, these two steps, they are steps of fermentation of alcohol. So alcohols on fermentation, they give you carbohydrates on fermentation, you can prepare alcohols. So, you can use grapes. Grapes can be converted into an alcohol, which is sold by the name of wine. So you can use grapes, you can use rice, you can use potatoes. From potatoes, the alcohol that you prepare is vodka. However, from whichever source you prepare by fermentation, the alcohol that you get is always only about 40%. Nobody can drink 100% alcohol. If anyone drinks 100% alcohol, he will die immediately on the spot. So the alcohol that you get in the market is not more than 40%. 40% alcohol is what?
Miss,
So yeah, tell me.
petrol is 100% alcohol, miss.
No, petrol 100% alcohol can be used as fuel. But the fuel that is biofuel, that alcohol also we say is biofuel because you can prepare it from these sources. But the petrol that we use in the vehicles nowadays, it is not alcohol. It is actually alkanes, a mixture of alkanes which contain 5 carbon atoms. It is generally a mixture of alkanes, pentane. They are all hydrocarbons. The alcohol is hydrocarbon. Petrol is hydrocarbon. So, C1, this also you should know. C1 to C4 alkanes which contain 1 to 4 carbon atoms. They are used as the, cooking gas. The gas that you use at home, cooking gas is hydrocarbons, mixture of hydrocarbons from C1 to C4. C5 to C7 is petrol. C7 to C9 is diesel. All right. And one isomer of C8, an isomer of C8, that is used as aviation fuel, which is the most, which is the best fuel available. So they are all obtained from petroleum. They are all obtained, hydrocarbons obtained from petroleum. All right, they are hydrocarbon. But petroleum is a non-renewable source of energy. That's why we say that, after a few years, we'll again be going on bullock carts because there'll be no petroleum. Which are the richest countries in the world which have a lot of petroleum? Which are those? All Saudi, Dubai. Why are they rich? Because they contain all the petroleum. We buy petroleum from them. We have small sources of petroleum, but that's not enough. We import petroleum, then we refine it. And so that is all. But we are working towards cars which can run on biofuel. Biofuel is actually alcohol. Biofuel. Alcohol which is made from living things like plants, which can be obtained from plants. Okay, so done. Now this is all that we need to do about alcohol. the word that I didn't mention is denaturing of alcohol. Denaturing of alcohol. So denaturing of alcohol is done by mixing it with methanol. Methylated spirit is prepared to denature alcohol. Denature alcohol means making alcohol unfit for drinking. Okay, so this also can be done by mixing some copper sulfate. What is the color of copper sulfate? You are all chemistry students. You know what is the color of copper sulfate? Anyone who knows the color of copper sulfate?
Blue mist.
Blue color. So what they do is they mix alcohol with copper sulfate. So it becomes blue in color. So you know this alcohol is not fit for drinking. So large quantities of alcohol now can be obtained by actually the alcohol which is used for industry cannot be obtained by fermentation, because fermentation you get only 40%. Then you will have to do fractional distillation. And you know, when I told solutions, I told you, you can make only 95% alcohol. You cannot make 100%. Absolute alcohol. 100% alcohol is known as absolute alcohol. How do you prepare absolute alcohol? Absolute alcohol can be prepared only from ethene. How? As Sai Kalyan said, you can just prepare it by addition of water to ethene in presence of H+. So that is how you prepare. Okay. So that's about alcohols. Now we will do the last bit of this chapter, and that is where we will do ethers. Okay, what are ethers now? Let us understand ethers. Ethers and alcohols we always learn together. Why do we learn ethers and alcohols? Ethers are, functional isomers of alcohol. So if I have CH3, CH2OH, I can write, what is the general formula? CnH2n plus 2O. That is an alcohol. So with the same formula, I can write a ether also. What will be the ether? CH3OCH3. Okay. So ethers can be considered as, like water. So what is water? HOH. So you remove H, both the H, and you replace it with alkyl group. It becomes a ether. Or ether can also be called the dehydrated alcohol. So if I take alcohol, two molecules, CH3OH plus another molecule, CH3OH, and I remove a water molecule from here, what will I get? CH3OCH. So ethers can be generally written as ROR. Both the R's may or may not be same. Let us learn how to name the ethers first. So to name the ethers, let us have, say, CH3, CH2, CH2, CH, OCH3, and here CH. This is an ether. Let me give you a simpler one first. This we'll name later. Let me make it CH3O, CH2, CH2, CH. Let me take a simple ether. Now this ether, it has oxygen and a different carbon chain on either side. What is a way of naming? First, take the longest chain. What is the longest chain? Propane, right? And this is the branch, prefix. On which carbon atom? On carbon atom number 1. So what will I call it? 1-methoxy. Meth, 1-methoxy propane. Okay. What will be this is first one. So how will I name the second one? This is 1, 2, 3, 4, and 5. So that is pentane. And on the second carbon atom, what do I have? Methoxy. So I'll call it 2-methoxy pentane, right? Let me do this one. CH3, CH2O, CH2, CH3. Now how will I name it? 2 carbon atoms. So what is it? Ethane, right? And this is present on the carbon atom. So what will I call it? Ethoxyethane. Okay, so these are different types of ethers. Why are these ethers important? They are, solvents, good solvents for organic compounds. Okay, good solvents for organic compounds. And in many reactions, you have seen sodium and dry ether. You see in Grignard synthesis, in Wood's reaction, many times we write ether on the arrow because they are good solvents for organic compounds. The other important thing is why they are good also because they are inert. That means they hardly take part in any reaction. Very few reactions they will take part. Let me also tell you a name of this ether, OCH3. Okay, what will I call it? Methoxybenzene, right? It is commonly known as anisole. Okay, so these are the few names of ethers which you know, which you should know. It's a not. This is not a very important part of ethers. Not many questions are asked. There are only 4 reactions of ethers which we need to learn. In fact, only 2 reactions. One method of preparation and one property. Okay, so let us see how we can prepare ethers. So first preparation. Today only preparation. Tomorrow we will learn the properties. So how can I prepare? First method is from alcohols. Okay, how do you prepare it from alcohols? It can be prepared by dehydration of alcohols. Okay, now dehydration can happen in 2 ways. We have done dehydration of alcohols, if you remember, CH3, CH2OH. If I take concentrated H2SO4, right, and 170 degrees Celsius, who will tell me what product will I get? Somebody tell me, what is the product that we will get? When I do dehydration, I remove water from the alcohol. What will I get? Any one of you.
Ethene.
Ethene, very good. You will get ethene, right? You will get ethene, CH2 double bond CH2. If you remember when I was teaching you this part, I told you it is very important, this temperature. At 170 degrees, you get ethene. And the reaction is what? Elimination reaction. But if I take concentrated H2SO4 and I react it with, keep the temperature at, so I take concentrated H2SO4 and I keep the temperature at 140 degrees Celsius instead of 170. Then dehydration happens, but in a different way. Between 2 molecules, a water molecule is eliminated and I get CH3, CH2O, CH2, CH3. This is ether. Now this reaction is actually a substitution reaction. It is not elimination because my product is also saturated. So this is a substitution reaction. You can also call it a condensation reaction. What is the difference between elimination and condensation? In elimination reaction, a small molecule like water is eliminated from one molecule. But in condensation, a small molecule like water is eliminated from 2 molecules, from between 2 molecules. Like esterification, you can call it a condensation reaction because water is removed by a reaction between alcohol and acid. Similarly, this is a sort of condensation reaction. But if you had to distinguish between whether it is addition, elimination, or substitution, then it is a substitution reaction. Okay. Now, when I taught you dehydration of alcohols, I have already shown you the mechanism. So you can look at my video later and see how the mechanism of this reaction. Now, second method of preparation is Williamson's synthesis. This also we have done along with alkyl halides. Okay, if I will remind you. Supposing I have CH3Cl and I reacted with CH3ONA, right? Cl will be replaced by OCH3. What will be the product? NaCl, right? And what will you get? CH3OCH3. We did ethers then. So what do you get? Methoxymethane. What did you get? Methoxymethane. Now you see what will happen. Now, supposing I have to prepare supposing I take CH3CH2Cl plus CH3CH2ONA, right? Very easy. I will get NaCl plus ethoxyethane, right? So what are these ethers? They are simple ethers because on either side it is the same alkyl group. Now I want to prepare what? I want to prepare this ether. On one side I have tertiary butyl OCH plus NaCl. I want to prepare this ether. Now how will I prepare this ether? Now I have two choices here. I could do CH3CCH3. One should be alkyl halide. So I can make the Cl plus CH3ONA. This is one possibility. The other possibility is I could have this one plus CH3Cl. Both of them will give me the same product. Can you see them differently? One, I took alkyl halide, tertiary alkyl halide, and sodium methoxide. And here I took a primary alkyl halide and I took sodium butoxide, tertiary butoxide. Now, this is a question for Sai Kalyan because sometimes you surprise me with your answers. So I think you will be able to get this. Now tell me, first one, this is reaction A and this is reaction B. Now A will be, both of them are new because they are reactions of alkyl halides. What are they? Nucleophilic substitution reaction. So what is A? Is it SN1 or SN2? First tell me. If I do by A method, am I doing SN1 or SN2? Who will answer this? Hari Raghav, can you answer? Hari Raghav? Hello?
Ma'am, the question is for A, right?
So A question is A part, is it SN1 or SN2? Tell me.
Ma'am, it's SN1.
It is SN1. Why is it SN1? Because it is tertiary alkyl halide.
No, because yes, ma'am.
The substrate is a tertiary alkyl halide. Now, Sai Kalyan, tell me about B. Are you there, Sai Kalyan? Yeah. So it is SN1 or SN2, the B one.
B is also SN1 plus.
Why? Why? What is the nature of the alkyl halide? These are reactions of alkyl halides. So CH3Cl is the substrate. That is the So I have to understand whether it is SN1 or SN2 depending on the nature of the alkyl halide. So the alkyl halide here is tertiary, so it is SN1. Here alkyl halide is primary. So what will it be?
SN2.
This is SN2, right? Now you should remember that if, this is a sentence which you should always remember. There is always a competition which always occurs between substitution and elimination. If your substrate is a primary alkyl halide, or if the reaction is by SN2 mechanism, then the major product is a substitution product. But if it is a tertiary alkyl halide, then major product will be elimination product. If I take the first combination, that is A, then I will get an alkene. This CH3ONA will work like alcoholic KOH, and I will get a elimination reaction, elimination products. But if I take a primary alkyl halide, then my major product will be a substitution product. This whole CH3ONA will attack from the back, and I will get this product. So which is the better combination? This combination is a better combination. So if my ether is a mixed ether, where one side it is tertiary and the other side is primary, then primary should be forming the alkyl halide and the tertiary should be forming the alkoxide. Primary alkyl halide and tertiary should be forming the alkoxide. Did you understand this properly or not? Okay, so if I prepare a tertiary ether which is mixed, on one side it is like this, on the other side it is primary, then tertiary will not be the alkyl halide. The primary will be the alkyl halide. Now let us take one more example. This time I want you to prepare this ether, O and CH3. Now again, two combinations are possible. One is chlorobenzene plus CH3ONA, right? And the other is sodium phenoxide and CH3Cl. Which is a better combination? And why? Hari, no, what is it? 4 only are remaining now. Sai Kalyan, you have not answered a single question today correctly. What happened to you? Now tell me this answer. Are you there?
Yes, plus.
Yes, tell me. Which is the better combination?
Second one, miss.
Second one, right? Because this bond does not break easily. So second one is a better combination. Very good. Second one is the better combination. Did you understand? So here you should have ONA and CH3Cl. So each ether, if it is a simple ether, no problem. You can take any alkyl halide and any alkoxide. But if it is a mixed ether, then you have to carefully decide which one will give me that ether. Okay. So we will end the class now. Before we end the class, I want you all to switch on your camera for a moment, one by one. Stop share. Sai Kalyan, can you switch on your camera? How are you? Today you don't seem to be very active in the class. I was looking forward to, did your parents meet me? I don't think your parents came that day, did they?
No, miss.
No, I was I was looking forward to meet them. I would have praised you. Today you are a little dull. What happened to you? Are you fine?
Nothing else.
Nothing? Okay.
Yes.
So just revise and do well. Now, who else is there? Ashwin, please switch on your camera. How are you, Ashwin? Did you understand what is taught in the class today?
Yes, ma'am.
Yeah, I didn't meet your parents either. What happened that day? They didn't come.
I was a little bit sick, ma'am. They was not able to come.
Okay, okay. So Hari Raghav, I met your parents. What did they say? I told them two things. I said, you are very intelligent. You can do much better. Isn't it? So in this test, you have to prove me right. You have to do well in this test, coming test. Okay. So only alcohols is there, alcohols and phenols. Please revise and do it well. Okay. Hariharan, can you switch on your camera?
I have Wi-Fi problems.
Okay, okay. So you were answering very well today in the class. So just revise. If you have any doubts, let me know. All right.
Okay, ma'am.
Okay, then see you all.
Thank you, ma'am.
Bye.
Thank you,
Bye.
ma'am.
Yes, ma'am. Thank you.
Bye.